Let's do it.
Hello.
Woohoo! We are back with an ASP.NET community stand-up, the first in over a month. I mean, Microsoft shuts down for the winter, basically. And
then it snowed, and my God.
Okay, but did it really? Because I was up there last week, and people were like, everyone stayed home from work because they're like, there's going to be a blizzard. And there was like maybe an inch of snow. And I'm from San Diego.
6 inches.
I actually, what's that?
I had solid 6 inches in my backyard.
Well, maybe in the backyard.
You don't understand.
Around the campus, there was not much there.
There was enough snow to cover my dog's feet. It was a disaster.
Oh, yeah, I stupid San Diego person where we don't actually use coats much, and I put all my warm clothes out when I was packing, and as I was running out the door, I left my coat, and I was actually going through security at the airport, and I'm like, where's my coat? Did I and then I'm like, oh no. So I had no coat for the week, and I did okay. But anyhow,
don't tell everybody, otherwise excuses for staying home for the whole week go away.
So it was, yeah, there you go. So we're back, and this is an exciting crossover show with the Cloud Native folks, with Shane and friends. So, and this show is also cool because it was by request. We have the thing that shows at the end of the shows where you can send in your request for show suggestions, and we got got several for microservices and containers and Cloud Native-y things. So, yay. Okay, well, I have just a few links. It's been a month. There's 1,000 cool things that have happened, but I just kept it to I seriously have 5 or 6 very quick links. So I'll switch over to those, and then I can get them done. Okay, do that. See if I remember how to computer over here.
Yeah.
Okay, wonderful. And then I think you switch the view to, okay. So we had the .NETCon focus on Blazor, and that was, it was last week. So that was we have .NETConf in September's, and those are full 3 days and tons of content and community speakers from around the world and all kinds of stuff. For this one, we had a focus event where we just focus on one technology. So this was a focus on Blazor, all kinds of new stuff. So, keynote overview from Dan. There was also a few cool announcements. So I'll show those in a second. And then there was a lot of great, kind of deep dive how-to stuff from community speakers as well. Deep dive things on authoring custom components. Jamie Angstrom did a really cool one with components where he showed some cool stuff with CSS and managing CSS and stuff. So great stuff there.
Yeah.
Two of the kind of Microsofty announcements there. One was the experimental mobile Blazor bindings. So this is this is one of those crazy crossover sort of things. This is building Xamarin Forms applications using Blazor binding syntax. So, and I spent some time while I was there. Also, I talked to James Montemagno in person. He's my go-to Xamarin Forms person, and so, the general idea here is, if you are a web developer, you're super comfortable with Blazor, Razor syntax, and all that, and you want to build Xamarin Forms. XAML's not super familiar for you and all that. This is a great way. So you're still building, it's Xamarin Forms underneath, and but Blazor syntax. So, and this is totally experimental. People are asking, when does it ship? Can I go live? And it's we're just thinking about it. But
yeah, I wanted to. We had a conversation this week with Dan Roth and the team, and we do want to stress that it's experimental at this point.
Yeah. Yeah, it's, I guess, even more experimental than the early experimental Blazor was, right? We're not even sure it's a good idea yet. We're just playing around with it. Whereas we're pretty sure Blazor was a good idea.
All right, Steve Sanderson, a cool thing he showed off using GRPC Web with Blazor WebAssembly. So this is something I ran into, and I don't know, Glenn or any of you folks want to talk about this. When I loved the demo that you did at .NET and then I was speaking somewhere and I was like, oh, I'll quickly set this up. And then I realized gRPC is not super simple to set up. And you actually need like an app service or stuff like that. And it can be a little more kind of complex to set up different parts of it.
But not actually app service, everybody listening, because app service it does not work on.
Correct. Yeah. This is a neat thing here. Also, another kind of sticking point with gRPC is browser support. And here, Steve's using gRPC Web with Blazor WebAssembly. So, yeah, walk through here. And then he updated the Flight Finder app, and his code is in here as well. So, yeah, so that's using that as well. So here he walks through kind of the simple case, and then he also links over and he's updated his Flight Finder application with that too.
Yeah. The problems with gRPC end up kind of boiling down to you need to be running somewhere that supports HTTP2, and not everywhere does yet for the moment. That's the biggest sticking point usually. And also when using WebAssembly in particular, it has a few of its own challenges because you're inside a sandbox.
I think the one takeaway from this article by Steve is gRPC Web is a different wire protocol than gRPC, because browsers don't give you access to full HTTP2 framing, like neither XHR nor fetch. The gRPC Web is a different protocol, so the backend that you speak to also needs to support gRPC Web.
Okay. And so is that difficult to set up as well? So
this blog post actually walks through it, and we've added support both on the client side so that you can consume it from like Blazor WebAssembly, as well as we've added support to our gRPC server implementation.
Cool.
So we've done both sides of the handshake.
Yeah, I guess I would probably describe this, and Sourabh can correct me, as like you do a non-gRPC from the inside the sandbox to something else that then translates it to gRPC for your backend service, right? So you work around those problems.
What about if I want to use asynchronous JavaScript and XML?
Then I am sure that there are many things for you to do.
Well, I mean, jokes aside,
gRPC is not one of them.
Yeah.
But jokes aside, there is a gRPC Web JavaScript client that you can use.
It's just not XML.
Yeah. I'm just thinking back, there's Ajax and JSON and all, like as we've gone over the years.
Yep.
Cool. All right, let me whip through these a little faster. This one, I actually got credentials to post on the Visual Studio blog. I'm so proud of myself. So I just want to do a call out here for February 24. We're doing this event, kind of like that Blazor one with Visual Studio for Mac. Two reasons I'm mentioning this. One is that's my new focus is Visual Studio for Mac, and as part of that, a good kind of reason this all fits together for me is that Visual Studio for Mac has added in a lot of support for ASP.NET Core lately. So .NET Core 3 or 3.1 scaffolding. There's Blazor support. There's all kinds of good stuff being added. So if you're developing on a Mac, developing ASP.NET Core applications, and you haven't been using VS for Mac, I kind of recommend it. So, and that's part of what that event is we'll show why. So, there's that. Okay, cool. Two quick posts from the community here. One is Shahed's doing a series, ASP.NET Core A through Z. So he's already, because we're 3 weeks into the year here, he's talking about cookies and consent. So he talks about, first of all, the previous releases, ASP.NET Core 2x, we had all the cookie management, gRPC. That's no longer in by default. So he shows how to wire that back up. And then he also kind of digs into some things in more depth, things like browser storage, and then also wiring it up for Blazor as well. So here he goes into the Blazor, the Blazor implementation and hooking up Blazor cookie consent as well. So stuff. All right, so the Shane guy updated his blog from app service to containers. So so Shane, my takeaway from this, it all looked relatively straightforward. This is cool. The little Alpine images are nice. You've got MySQL for the data. One thing that jumped out to me was that you're doing some things to make it survivable and prevent data loss in case of a container fail.
Yeah, this is kind of like, practice what you preach. To be honest, I've been running, and it's all in the post, but I've been running, Ghost on Azure since before Azure had resource groups. So for those of us that can remember how long that's been, it's well over 8 years. And I was getting to the point where it was just super hard to update the actual application. And if we can we've all lived that kind of life now, and that's kind of the lift and shift to containers story now, where maintaining legacy applications is really difficult. And I think I've kind of jumped into this probably, 4 or 5 times over the last at least 5 years, going, I need to update my blog backend or the version of it. And it was super hard for me to kind of update the data or update the actual app. And I'm going, every time this thing updates, it's a pain in the butt. And finally, I took the holiday to go ahead and do it and bite the bullet. And now I'm kind of set up for success where I can just iterate the container and the actual application portion of it runs. I've got my data in MySQL that runs on a service. And then I've got everything else in like storage and kind of how you would break up that microservices or kind of cloud native architecture the way you would hope it would all work and not break down. So if my container fails, I don't care. I can just spin up a new one and everything's going to still work. So it was a fun experiment, and it's all running on Azure. And, I've got it all CI/CD with DevOps, and now I'm learning GitHub Actions and all these things too, to try and move to that new thing too. So it's cool.
Nice. Cool. All right. And then one other thing before I pass it over. So we're doing this crossover show. Shane, you've started up this cloud native show. This link and all the links will be shared out in the show notes, and I'll pass them out over the chat. And then this short link here to the Cloud Native Show, you've got AKMS Cloud Native Show.
Right.
So tell us about the show.
Yeah, first off, this is actually the first time I've actually been on the show. I've been watching the show for a long time, and obviously I'm a blue badge for a while. Glenn and I talked about this, I don't know,
at least
probably
the
last September or so.
Yeah, it was at least the last MVP summit, maybe a bit earlier.
Yeah, and we said that when it comes to cloud native apps, kind of .NET and .NET Core are really not in the conversation a whole lot. So how do we kind of bring focus to how we can build all the components of cloud native applications and kind of what's known as 12-factor architecture with all of the things, not just .NET, but also Azure and all the things that kind of go around it, the engineers, the architecture patterns, and then all of the services that we're either involved in at Microsoft or in the open source world. So we kind of put together and laid out a plan of, what are the things we wanted to talk about, and really quickly we're like, we've got probably 20 shows to start with that really tell a quick story and not dumb it down, but tell a simple way of building these types of apps with the stuff that we do every day. So we first sat down with, the very first show was with Brendan Burns, and who better to kind of describe, what is cloud native, and that was episode 1, and we're up to at least 8 published shows right now. We've got a couple of live shows out there too. Yeah. And the latest one we did with Sourabh and talking about GRPC and the work we're doing open source with Google and making that happen for .NET Core. So yeah, it's a lot of fun doing the show, and Glenn's been instrumental in helping us kind of guide that way too.
Cool. All right, well, that is all the links for this week, so I will pass it over to you folks.
Yeah, I guess I would say about the Cloud Native show that it's almost like 2 shows, I guess, 2 related shows. There's these amazing recorded, kind of produced videos that Shane puts together with kind of experts, or at least people that talk about things, and like just talking about Cloud Native topics, and then periodically, every month or 2 is the goal, eventually, depending on how everything goes and how much people like it, is that we do a live stream where we go a little bit deeper and we try and build up something and give people a chance to ask questions. So,
yeah. So the first show we did, I don't recall, it was after the first 4 episodes. Glenn and I really just sat down and said, okay, based on the first 4 shows, let's build out a simple app based on the first 4 topics we talked about. And now that a couple of more have come out, on February 5th, Brady Gaster and I are going to sit down in the studio and then just add on to that based on the last couple of topics. So we'll implement some gRPC in there. We've got a show on container registry coming out, and we'll throw that in there as well, and just kind of build on that. And really, it's on Twitch and YouTube and all the various places where we kind of restream all these things, and just kind of build on the questions and make it interactive for a couple of hours. It's a lot of fun.
Yeah. So there was a couple of questions I noticed swing by in various places. Someone was asking about when we're going to start previewing .NET 5. Settle down. We only just shipped 3.1. But but the answer to that is we've said we're going to ship .NET 5 in November, so you'll probably start seeing previews of that dropping soonish, and we'll have probably a very similar number of previews as what we had of 3. So if you're looking forward to whatever you're looking forward to that's going to come in .NET 5, it'll probably not be too far away, but I don't think that we've actually nailed down a first preview date yet. If not, I'm sure that someone in the Chatterverse will correct me instantly, so that'll be fine.
So I think Sourabh's got some pretty cool demos on microservices and gRPC and all kinds of Prometheus and all kind of fun stuff we want to kind of throw together.
Yeah, so let's just throw straight over to you then. Your answer, Ab?
All right, sure.
Yeah, all right.
So I have a couple of demos to show today. They mainly involve around how you can get your .NET app running in a Kubernetes cluster, including deving on a Kubernetes cluster. What I've done as a precursor to set up for this show is I've created an AKS cluster. I've created a ACR registry that's attached to the AKS cluster, and I've set up an Nginx ingress in my cluster. So now that I have the basic setup, that's pretty much all I need to deploy a web app and start routing traffic to it. So I want to show you my local workflow. There are multiple open source tools out there that you can use to achieve this. I happen to have a personal preference, so I'm going to show my demos predicated on using that. But the takeaway from this theme should be that you can use .NET and be productive in Kubernetes, and there are a lot of tools out there already that help you be productive. So I have a design doc from Scaffold up on my screen right now, because Scaffold is the tool of choice that I use. The reason why I use a tool here is when you go from source control and building and making changes all the way to deploying to your cluster, there are a couple of steps that everyone goes through. You start with, obviously, when there is a source code change, you detect the source code change, and then you build an artifact. Now that artifact is probably a runnable container image, and then you probably test it, you tag it. You need a way of differentiating this artifact from previous artifacts you produced, and you obviously want to go ahead and publish these artifacts somewhere. Like if you're using container registry, it's probably to a container registry, and then of course deploy your Kubernetes manifest to make sure that your resources are updated for that. When you're working in a local dev flow, the expectation to have to do 15 of those steps manually and not get everything wrong is difficult. That's why tools like this exist. So I had this architectural diagram, and this is what I'm going to be using today. But I'm using Scaffold or other tools. I think tilt.dev is another one, which people can try out. So let me go ahead and jump over to some code and show you what I can actually do. So I have my Kubernetes cluster deployed, and if I go hit it right now, I get the I don't know if folks can see that. It just says default backend 404. So that's my ingress with no traffic routed to it right now. So I've gone ahead and created a simple web API application. This is nothing more than the template application.
Somewhere Hanselman just sat up and slammed the table, and he doesn't know why, and it's because nobody can see what's on your screen right now.
Let's try
Much better.
Yeah, I got most of the windows right size. I might have missed a few. Okay, so there's really nothing here. This is just a default web API application, right? So just the usual. I say it's just that, but I've obviously added some stuff, which I'm going to talk to in a second. but let me show you what my default experience looks like right now. So I drop into my command line and I go scaffold dev, right? And so since there was no change to my application, it already found the image locally. And so now it's deploying a couple of things. It's deploying my .NET service, right? And creating the associated Kubernetes deployment with that. And in a second, I will show you my Kubernetes YAML to say what's going on. And I also have my ingress resources being reconfigured to route traffic to that endpoint. There are a couple more things that I'll get to in a second.
So this is from a very basic, from a cluster that effectively has nothing, or maybe an ingress controller set up. You run this one command, and it deploys your app and configures everything so that all the traffic just routes to it easily.
And I do want to point out that if you see the command I ran scaffold dev. This is the dev workflow. So it's also actually watching for changes. So first, let me go ahead and show you that my app is deployed, and just so you believe me, cool, right? My API is deployed, wasn't much, right? Of course, there were some config files dropped in, but that would be a reusable artifact that you can use. If I go in here and let's say, where's my controller, my weather forecast controller? Let's just make some change, okay? I'm going to keep it relatively benign because the purpose of this demo is not to show the app. So you see, it found a change, and it's actually rebuilding my app using the Docker file I've provided. A lot of layers were already shared, so I didn't have to do much besides push the changes. And now,
so this is also effectively a combination of .NET Watch for Kubernetes, where you're watching your program, your source code for change. Every time you change any code file, it already builds everything and pushes it.
But more so than a code, because remember, you also have infrastructure as code files like your Kubernetes configuration, so that can also change. All right. So if I go in now and
so question, since there was a reasonable pause moment, was scaffold is your creation, and the answer is no. It's a thing that exists. If you want to go pull up the scaffold website, it is spelled with a K, I believe.
It is.
That when you first typed it in on the command line, I'm like, but you misspelled.
No, it is spelled with a K.
It's not a tool that I created. It already exists.
So presume is it big in the URL so that people can look at it, or whatever.
I don't know how to do that.
Okay.
But scaffold.dev.
Yeah.
Scaffold.dev.
Cool.
Scaffold with a K.
So,
Cool.
were there any other questions, or should
That's
I
all.
proceed?
Keep going.
Okay. So right now, let's go back to this. So I made a change. It picked up my changes, and I redeployed it, right? So what exactly did I deploy? In addition to my app and my app artifacts, there was some infrastructure as code that I mentioned. So let's go look at the actual Kubernetes manifest that I deployed. So I deployed, let's look at my deployment first, right? So there are a couple of things in these manifests that I don't want to speak to just yet because I want to build up to that. So let's look at the relevant parts. So it's just, here's my here's my app name, here's my image, right? I just called it .NET example. There's not much else, and I said, hey, map to port. It's target port 80 inside the container, 5000 outside for the load balancer, and then I also deployed this hello world ingress, which says, hey, route traffic at /* to .NET service at port 5000. That's how my traffic is getting routed. And you see, if I go make a request to, like, just sanity check, right? If I make a request to root to the app, get a 404 because there's no route configured there. Right? That's pretty straightforward. Now, once you've deployed your application, there are a couple of common observability concerns that you want to solve, because there's no fun having your application if you have no idea what's going on, right? In my contrived example, there was nothing wrong, so I was lucky there. But you probably want logs and metrics, right? Those are the two pillars of observability. So let's look at how we'd observe that. So this application, as you can see from my command line, is actually spewing a bunch of JSON. Like if I go make another request, you see it spewed a little more JSON to my screen, right? And this is effectively the logging. So what I've done is I've taken the default app and I've replaced the console logger that we have in the box with a console logger that outputs, that serializes to JSON. The benefit of this is when you run in AKS, there is a log collection service. So there's a AKS plugin that actually runs as a Kubernetes daemon set that runs FluentBit, and it actually harvests all the std out logs from your container and makes it available in Azure Monitor. So if I jump over to Azure Monitor, and so let me just make this, I had the query already in, so let's give it a second, or I guess 6.8 seconds to be precise. You can see I have my container logs now available in Azure Monitor. The benefit of making it structured logging, and I happen to pick JSON, is that Azure Monitor can be a little smart about it. So I've actually, if you look at my query, I've done like a transform.
Zoom.
Ooh, let's see. Hide this, so there's more visible. So what I've done is from the actual raw value of the log entry, I've extracted these JSON fields to make more sense of the log. So if I go back, how do I, oh shoot, I have to, okay. So what I've been able to do is, because it's structured output, I've been able to do things like extract the timestamp, extract the message, path, method when they're available, stack trace if I have an exception. So I've been able to get this structured logging available in Azure Monitor, which is great. Now if I have like errors or other issues, they're clearly visible here, and they're structured and easily searchable in the way that I would want my logs to be. The other thing I just want to bring some attention to is there are also these span ID and trace ID elements. Right now they are unused, but since we support distributed tracing built into the box, especially the W3C format for distributed tracing, we have a span ID and a trace ID associated with every request. Now, if I were to have multiple applications talking to each other, all spewing their logs into the same log analytics workspace, I could track a request with its span as it spans across multiple apps and see a true distributed trace.
Yeah.
So
yeah, you'll be able to watch the single request make its way through multiples of your services, and then potentially all the way into like the Azure services that you're using, like blob storage or something, if you pass it all the way through.
That's right.
There was a question about Azure Monitor, and what do you need to do to get an Azure Monitor like instance thing? So
correct me if I'm wrong, Glenn Shane here, but when you provision an AKS resource, you have to provision an Azure Monitor instance, because in addition to your app logs, even your like Kubernetes logs and the infrastructure logs are sent to that Azure Monitor workspace.
Yep. Yeah, you get one for free, basic for free. I don't know if it's for free in terms of paying for it, but I know it's free in terms of it just happens when you make an AKS cluster. And it is also the same sort of thing you get when doing app insights and stuff like that. Yes, to fully answer the question.
I just want to point out one thing. I've been using the word log analytics and Azure Monitor interchangeably.
Yeah.
I apologize because I forget what the right term for the product is, but I hope you will bear with me here. Yeah. So just looking at my Azure resource here, it says log analytics workspace. Mm-hmm. So I'm gonna go with that as the official term. I think we lost Shane.
Yeah, it's fine.
Yeah.
So I did show you logs. The other thing that I do want to show you is metrics, because logs are great if you know exactly what you're looking for, but if you have spew from multiple applications in a single log analytics workspace, it's a little hard to make method out madness, right? You could have way too much information. So metrics are great as they give you early visibility into what is going on in your application. Like, as .NET developers might be aware, they're like, the perf counters from the good old days that you knew if those counters went out of some standard deviation, you had a problem on your hands and it was coming soon. So the other thing we really want to do is make sure that counters are available. So before I show you the demo, just a little brief background. So we've made some improvements in .NET Core 3.0 and 3.1 subsequently, where we've exposed diagnostic information from the runtime, like metric-based information available via a new primitive called event counters. Now, these event counters can be consumed both in process via the event listener API, which I'll get to in a second. They can also be consumed out of process, and that's how tools like .NET counters works, for example. So let me switch back over to my application and tell you how I've actually consumed event counters. So what I have here is I want everyone looking at this to squint a little hard right now and pretend like this is the ideal world. Obviously, this is demo, and things are obviously subject to change, but this is how it perhaps could be. So if I show you my startup file, I've added something to configure services that says services.addMetrics. So I've actually, added my own library in here that does some stuff in addition, which is expose metrics as a service in your application. The other thing that I've done in my, if you look at where I've configured endpoint routing, is I've said endpoints.mapMetrics endpoint. So what I've also done is, this thing isn't configured right now, but at a known location, which is /metrics, I've exposed the metrics produced by that application, right? So given that my app is already deployed, if I go back over here and I make a request to the /metrics endpoint, any guesses for what you'll see?
Logs.
No way, Glenn. Oh. You see metrics. So these are so I've, I think, surfaced all the 14 event counters, maybe more, that the runtime generates.
How quickly does it update? If you keep refreshing it, do these numbers going to change every time?
So these, so I cache them every time they're synthesized, and they're synthesized once a second, because that's how I've hard-coded in my app right now. So every time I do make a request, you will see that there are new values available.
Yep, I can see the allocation rate changing.
Is there a reason they're not serialized in a format like JSON or something, so you can parse them out?
Yes, there's a specific reason I chose this format, because this is in fact the format that Prometheus expects when you point it to your application and say, hey, please scrape my metrics.
Got it.
Well, is that a running average or a materialized value for each of those metrics is a question.
This is the instantaneous value. Yeah. And based on how the metric is synthesized in the runtime, that could be amortized over some observation window or not.
Yeah, depending on what the metric is and what
depending on what the metric is.
Yeah.
Now this is obviously something I was peeking at your code. You said to squint, so I did, and I looked at your files there. Is this something that you're kind of POCing for us to put in, kind of built in for us to have as a kind of an add-in?
It's a question I don't have an answer for, because
Glenn was nodding yes.
I was nodding yes to the question.
That is a great question, and that's something we have to figure out, because there are existing libraries in the ecosystem. There is a Prometheus.NET library that has significant usage, and it does offer some things that this POC doesn't. It has stuff like histogram-based counters. I'll give you an example of a metric like request latency. Average or instantaneous value is kind of a useless measure. What you really want is like P75, P95, P99, right? Because you want to find outliers in your request latency. So there are some things we're looking to do, even up including changes to the runtime to expose this richer fidelity of information. But the Prometheus.NET library, as an example, uses, I believe it uses diagnostic source or event source to synthesize it. Sorry, it uses event source. So they can expose a richer fidelity of information that my POC doesn't. The compelling thing about what I showed right now is it has no external dependencies. It just uses things in the BCL or in ASP.NET Core.
Yeah, which means it is definitely a candidate for something that we would ship, but we haven't necessarily agreed that it's worth it right now. It's literally impossible to parse a file with names and values separated by a space. Snable, you can't do it. It's it's computationally impossible to parse a file like this. It's the way it is. Has to be JSON.
Now, I know that this is just a simple demo, right? This is probably the equivalent of a Hello World example when it comes to these types of this type of data. I'm curious have you, Sourabh, have you considered, I forget what the actual term is, but when we start to watch something, it starts to slow it down. Like, how are we, have you considered the performance effect? I think it's called the observability effect. When we start to look at these and start to produce the output here, how it might affect if we did ship it. Again, this is all just
so so we're working our way from the bottom up, right? So you want to make sure synthesizing the metrics in the runtime aren't expensive, because you want to start from the bottom, then work your way up into the web app stack and what the cost of serving this is. So we have looked at the runtime. Fun fact, the Tech Empower like benchmarks that we run internally to track our progress actually collects these metrics for every app run that we do. And we did not, it was within observation error for the impact of synthesizing these metrics. Right? Okay. But those were synthesized and egressed using the out of process egress mechanism, not via an endpoint in the application. So to answer your question, we absolutely are thinking about it, but we're starting at the bottom. Yep. We're starting in the runtime, and we'll work our way up to see the impacts.
There are also other ways to expose these types of URIs that are potentially interesting, right? Like, you could imagine sidecar containers that have this endpoint on them that aren't actually part of your application, for example, as a completely alternate way of doing a very similar thing, but a very, very different implementation, right? So we're still talking about it, and we'll see how it lands.
Yes, sir.
So cool. So jumping back to the demo. So I've shown you how my app actually exposes this, but it's really no fun unless it's persisted somewhere, right? This is just an endpoint that you have to hit. So the thing that John's question did lead to, and I did mention before, is this format is the same format that Prometheus expects. So funnily enough, AKS has a way of configuring it to scrape Prometheus style metrics. So if I jump back over to my application and I'm going to show you the Kubernetes config for I believe this is the Azure monitoring agent config. So I apologize to Azure Monitor folks if I'm showing the old and ugly and outdated way of doing this, and there might be a cleaner way. But right now I've done the infallible way, which is drop a config map, and this is the config map used by the scraping agent. So we'll skip over stuff that doesn't really matter. The interesting thing would be this line of configuration, and Glenn will yell if it's not large enough for people to read. But I said, so it's just an array of Kubernetes services to scrape metrics from, and it's my app, my service name. In Kubernetes land, it's service name dot namespace is how you can route to anything else. So I'm saying, hey, scrape all the metrics from my service, which is exposed at, on port 5000, because that's how my app is set up, and the metrics are endpoint. I will show one more thing for the sake of completeness, because I do believe that the right way to do it is through something like annotations, right? So you don't actually have to drop a config map file in. The agent knows that for every new deployed service, it can just look at annotations in the service and use that to scrape it. But either it's something that isn't quite supported yet, or I wasn't able to configure correctly. But I'm just showing this for what I do think the idiomatic way of doing it should look like. So anyway, now that we've done this, something I did not mention is I showed you when I deployed my app, there was a deployment file and the ingress file. The other thing, of course, that I did deploy was this config map for the scraping agent. So if I switch back over to my terminal and see the logs, you might have seen there's a lot of spew on my screen, and that's coming from these /metrics HTTP get. So what I've done, so since I've deployed the config map, the Azure Monitor agent is scraping my app. I believe I've configured it for every 5 seconds to collect all those metrics, right?
Just for a second here, somebody said that they're lost. Oh, Glenn, you said you're going to recap.
Yeah, I want him to get to I want him to get to the kind of money moment, and then we'll come back and walk through it again so that everybody understands it. So because
this is pretty deep, so
just I'll let him get through to where he's showing some stuff that's cool at the end of this, and then we'll walk back and show it, make sure people understand the pieces. Yeah.
So what I've done is I've taken these metrics, and since they're being collected by the script agent, they are available in Azure Monitor. So if I switch back over to my browser and go into, I believe I had a query somewhere here, or let me just copy it from here. So I picked a simple fun query, which is just, did it run?
Mm-hmm.
No, it didn't. Okay, there you go. So if you see here, and I know it's not the best thing, the metric I've queried for is requests per second, and you see this nice spike in the chart because right before I walked into this room, I pointed a load generator at it, so I knew this graph would have a nice spike. But the other thing that's available is it's not just requests per second. If I go oh shoot. Sorry, I was gonna get you the list of all metrics, but it is. Let me do this. Sorry. Let me just remove the chart so I can get all the values.
Mm-hmm.
Let's scope it down to the last 30 minutes.
Yeah.
Okay, so there you see, I'm basically I'm collecting all these metrics. I had shown you one visualization, but you can do fun stuff in Azure Monitor, like, obviously one is observe the values, but set alerting on it. You can set yourself send yourself an email if your thread pool queue length becomes too high or something like that.
Right.
And take reactive measures based on that.
Okay, so let's walk back a little bit from this. What we did here is we added to the application a diagnostics endpoint, an endpoint that just has the metrics in it, right? And it is the format that Prometheus expects to get. It's the Prometheus format. So if you were to point a Prometheus instance at that URI, it would work the same that we did, the same as what this demo did. Then we did basically some AKS stuff that anybody who's not been using AKS before probably won't know, or some Kubernetes stuff, I should say, to get an agent to hit that endpoint and put it into Azure Monitor, the same system that has all of our logs in it. That's what all that demo was. So all of that stuff in the middle that's kind of, some people were like, well, I don't really understand a lot of this, was really just a long way of adding the line of code to Kubernetes that said, hit this URL and grab the metrics from it and put them into Azure Monitor for me. If that all makes sense. Does that sound right? Yeah. And so if you were trying to do this cross-platform, because I see some people in chat who are like, okay, this is super specific to Azure. Everything that you did is exactly the same if you were to just be using Prometheus and various other common technologies, because that is the format. The metric endpoint is the same format as the Prometheus expects, and as such, it's all the same, except in the bit where he had one line in a config file that said hit this endpoint would be in a Prometheus specific configuration rather than somewhere else.
And actually, to speak to that, I also showed what the idiomatic way should be, where you won't have an Azure specific way of doing it. It would just be a annotation saying, hey, by the way, for whoever cares, my app exposes metrics on this endpoint, and here's the port and the scheme.
Yeah. Hopefully that makes sense and answers a bunch of the kind of questions and stuff people had about it.
So it is messy today, but that's why I said if you can squint hard, let's say we can get to a place where you deploy your .NET app and all of this just works.
Yeah. The goal at the end of a lot of work would be the first part where he just runs the scaffold command and the app is running, and then he can just hit this and see all of the things without changing his app any further. That would be the old ideal end state, and we'll see how close we can get to that over time.
Okay, so all the metrics handling and all that is just kind of part of the new project experience, it's just included in there.
It's part of something. It could be part of a new project experience. It could be done several ways. Yeah.
Okay.
So I do want to show, I just want to point to this repo. It's GitHub/myname/metrics, specifically because the Azure question was asked. This is just a .NET app that exposes a metrics endpoint with Prometheus configured to run in the cluster. And this is the Prometheus UI showing the value of my counters. So if you are worried, hey, the tech I've shown is way too Azure specific or something, that isn't the case. And I hope this is a runnable sample, because just looking at the date, the last I touched this was November 15th. But it should show you what you're asking for.
Okay, I'll add that link to the list for this week.
Do we see this as Glenn or Sourabh, do we see this as a kind of an inner loop development cycle for just any project, or do you see this somewhere? Where do you see this in the developer's lifecycle? I'm looking through the scaffold tool, and I'm like, hey, this is something I have to have like in my tool chain now, outside of VS or VS Code. Like, is this something that I should be looking at now, or is this something that this is a pattern that we as the team are looking to emulate? Like, where do you see this sitting?
So I can take a stab at answering this, but I will preface this with, this is my opinion and not the team's opinion, where I do believe that these tools, you can be productive with them today, but the concept count is way too high and something unreasonable for a developer whose passion is in Kubernetes. If your passion is just like, hey, I want to finish my project, Kubernetes is a means to the end, I do not care about all this stuff. So I believe we're at the point where there is tooling, you can be productive, but it's an unrealistic expectation, and our goal is to make that easier for you.
Yeah,
that's a good point. I think that, and thank you for answering it that way, because I think we find that there are on the spectrum of developers, there are developers who want to just check in code, and then there's developers like you're mentioning there, where I want to know all the nuts and bolts, and I don't care if there's 100 tools to get my job done. I'll figure out how to chain them together. So this probably is closer towards that end, as opposed to checking in my code, right?
Yeah, then there's kind of an intersection, right? Or there is a spectrum, obviously, as with all things. But where it starts to become interesting is, even if you're the person who wants to only check in code and you only care about the thing that you're working on, but you don't operate in isolation almost ever. So then the question becomes, well, I only want to focus on my code, but I know that I have this other service that somebody else builds, or maybe I need this database running, or I need this thing over here. And once you start operating in that ecosystem, how are you doing it? Are you doing it on? Are you doing that via having your own AKS cluster where you stand everything up and then you dev on it? Well, then something like Scaffold sounds super amazing. So you leave all the other stuff running and you just dev on the bits that you want to, and you work on the bits you want to work on. Or are you going to run them on your local machine, or are you going to do like a bunch of things, right? So what you want to do to manage all of those dependencies is different for everybody as well, and it can be a hard setup. And it's not unique to Kubernetes or to microservices. They just exacerbate a problem that can exist. I've seen plenty of other organizations using, .NET Framework on IIS on Windows servers with ASP.NET and have the same problem, because they have multiple teams and perhaps multiple websites that make up one like solution, and they have the same problem.
Sure.
Yeah.
Mhm.
Sure.
So, there's some chat reaction that's like, wow, this is difficult to debug and, to understand. Like, you need a lot of knowledge to be able to run and handle this. Is this something where over time this gets, like with the kind of work you're doing with metrics and just kind of in general, do you think things will get simpler for .NET developers, or is it always just going to be, you need to know all the stuff?
Yes.
Well, I don't even think that it's .NET specific. I think the language agnostic. Even if we did this whole example in Go or Node or whatever it was, I think that the complexity of getting this all set up and working is probably about the same.
Yeah. So
I think that tooling in general across Kubernetes development, we know as an industry, it's not easy. It's certainly not there yet, and knowing that when stuff breaks, that is always our biggest challenge. How do we debug our, 100 containers or 100 services running in once? It is a challenge that we are actively trying to solve on a daily basis.
Yeah. I think the overall, I mean, if we're talking about predictions that could be entirely and wildly inaccurate, over time, if you talk at like Kubernetes Conf or something like that, you talked about there was a lot a couple of years ago about running Kubernetes and doing everything in Kubernetes and how Kubernetes works. Then then there was a year or so ago, there was a lot about, managed Kubernetes, we'll have managed Kubernetes instances, you won't have to worry about machines, about clusters as much. And I think more and more as we go forwards, we'll start to see Kubernetes fade more and more into it as a detail and an implementation detail of the background. And you're starting to see that more and more. And it'll be more like serverless was, more like functions was, something more like an app service that runs that happens to use the power of Kubernetes to give you a more powerful app service, for example. You could imagine things like that happening or being built, and I hope they do so going forwards. And I would expect that to happen across a lot of languages.
So it becomes more just part of the infrastructure that's hosting your application, and you can focus on.
I don't really remember this because I don't know that I was in the industry at the time, but like I imagine the really early days of virtual machines were a lot like this. And then eventually nobody thinks about them, and then eventually they go away.
So I do want to answer John's question with actually a demo, because it is an example of something of like debugging specifically, like, oh my God, debugging a cluster is really hard, right? But with the right tooling, it could become like commoditized and as easy as just attaching to a debugger anywhere else. I want to show you a demo of that working with existing tooling, and right, so that might help answer the question, show the direction we're heading. So switching back over to my screen, let me switch over to this. I should have cleared out my app before I asked you to switch, Glenn. Right. So I have another application running here, right? I just want to show you this. So this is a little more than the Condron example. It has a back end and a front end, and I believe has a Redis cluster as well. So this is great. I deploy this to Kubernetes, but then I want to debug, and that becomes a little challenging, right? So how would I debug? So I'm going to show you how I actually went through this manually. I went on a self-discovery journey, and then I realized, oh wait, there's a tool that exists that lets me do this with one click. So to actually debug your .NET application, it's pretty similar to the remote debugging experience through VS or anywhere else, where we actually have a process running alongside the target process that exposes like either a web endpoint or like a TTY that we can connect to and send commands. So if I go back over to my scaffold.yaml file, which I don't think I showed in much detail. So I wrote this custom profile that says, hey, instead of building this Docker file and tagging with this image, use this alternative Docker file, which I've called debug.dockerfile. So I can always run like scaffold dev, and I can specify a profile, and I call this the debug profile. But let me show you what it does. So let's go back over into my app, and I have this debug Docker file. So in addition to building my app, which is this fun stuff, let's actually look at the last couple of lines here. So there's the install dependencies for Visual Studio Remote Debugger, and then actually add the add VSDBG inside my container, right? So now when you run your application, there's another there's VSDBG in the container that I can connect to. So and let me show you so this is perhaps uninteresting, and if I go too much in the weeds, someone
in chat literally just said this is interesting. As you said, perhaps this is uninteresting. So
okay, then I will go on with it. I'll also show you my VS Code launch settings, where I'm like, hey, I'm gonna add this attached to Kubernetes debug profile, and what I'm gonna do is I'm gonna connect to PID1 in the container, because we know, like, in a container your process running is PID1. And what I'm going to ask it to do is go to this location and run this application. So what it actually does is it launches VSDBG, and VSDBG has this sort of interpreted mode where you can send it commands, and that's the same protocol that the Visual Studio Code debugger uses. So this way I'm able to debug, set a breakpoint inside the container.
And you already said that the difference between your dev Docker file was that it includes a debugger, right?
Yes, so I can just jump back to that real quick. The only difference was I'm installing the dependencies for VSDBG and adding
the debugger. Yep.
Right. So if you have this in your Docker file, I did a separate profile. If you think it's benign to bake it into your Docker image, that's also a possibility. So I'm going to jump over to my other app because this is manual and convoluted. So there is a Visual Studio Code extension by the fine folks over at Google called Cloud Code, right? And it works well with Scaffold. So I have another app. This is the application I was talking about, which was front end, back end, and Redis. So if I look at my Scaffold file, it has all my manifests in here, right? So I'm going to go over here, and instead of running Scaffold from the command line, like I've been showing you thus far, I'm going to use the VS Code tooling in here. So let me just make sure my Kubernetes cluster is in the right state. If I get that, the default 404, I know I can proceed. Actually, I believe my app is still running somewhere.
I mean, I assume it would be. You didn't do any work to tear it down.
Yeah, so I need to figure out why my app is running. Should give me. Glenn, do you want to give me cover and talk about something? While
No,
I
I'm
figure
just
this
going to
out?
let you. I'm just going to let you flounder. That seems like the best
We're just gonna let you
opportunity.
swirl.
Yeah.
Okay.
Everybody has this moment in their presentation career where they realize that there are, whilst hundreds of people are watching them, they have to type a bunch of commands, and it's super uninteresting.
Well, I think that what's happening here is when he talked about having a container that has the VS debugger in it, this is very similar to how Visual Studio works too when we attach and debug the container.
exactly
the difference is that we actually have a virtual directory where we're mapping that debugger into the container that allows us to debug those Docker containers.
When you use the Docker tools in Visual Studio to kind of F5 into Docker to run in your app in a Docker container, it volume mounts the debugger from the local machine into the container to get the same effect as what Sourabh was showing by building an image that has a debugger in it. Yeah.
Okay. So I was able to salvage the thing I was trying to do is run 2 different demos in the same cluster, and I forgot to tear down my resources. So I didn't want to like have my next deployment stomp over my old one. So I got that done. So if you see down here in the corner, I have this Cloud Code. So I'm going to go ahead, click on this, and it says there's like a new application, and there's a deploy application and deploy application continuously. That's the equivalent of typing scaffold dev in the command line, right? So I hit, and then I choose the default profile. I'll speak to the other one in a second. So let's just ignore this for a second. So right now it's doing the same thing as running scaffold dev in the terminal, but there are a couple of neat things that it does expose. So you see the 0 out of 5, I had 5 different services to deploy. So it's still in the process of deploying. So let's give it a second.
It would be nice to get an init container that will drop those files if/when you need to attach. That work? Suppose it might.
I'll have to think about that, but right now it's not apparent to me why an init container would be better than just having it as part of the mounting a volume which has VSDBG in it.
Well, I guess it would be,
And an init container cannot give you the dependencies that you need. Like if I need to apt install something, that wouldn't be the right way to do it. So.
Yeah, you'd only be able to get things that you could retrieve off of URIs and then put onto as files on disk, right? So if the debugger has some other dependency, an init container wouldn't help.
So this is still taking a second because this deployment has a Redis cluster in it, which isn't probably the wisest thing for a quick demo.
Yeah, that's the question, Arctang, which is, do I always want the debug files available, security, etc.? Yeah, that's the question, right? And different organizations have different answers. I will assert that if you're running like .NET Framework on Windows, you've always got a bunch of stuff like that available on the machine. There are potentially policies you've got that have locked them down on those machines, but they're kind of there. And yeah, that's a question that you have to ask yourself. It's super like situational and specific to different people on whether or not the benefit of being able to randomly debug is useful and beneficial to them. In general, most places I've worked in the past would say no and don't debug in production. But you know, if you're using the cluster if this is a dev cluster, then absolutely. So
well, you know, is that something where because you can like segment different parts of clusters and stuff, can you spin up like in the generally production environment, but it's a dev tagged?
You could do that with a product like Dev Spaces, right? You can do things like that.
Okay.
And I can't remember the alternate that's not Azure specific, but anyway.
But I mean, I think John's question was more specific. Like Kubernetes does have like role-based access control, so you can really like clamp things down if you want.
Oh, sure.
Yeah, so I could say like I've got my huge cluster, and I could say spin up just one debug in this cluster.
I see, yeah. And I guess the answer that I gave was more about once you do that, how do you get traffic there and also use the other instances? And that's where things like dev spaces come in, which is like, how do I spin up a new dev container in my production cluster and have just my traffic from my test flow go to it and everybody else's production traffic go to the production instances, right? Something like that.
But I think more broadly to John's question, yes, you can do it. Like Kubernetes is just infrastructure. You can do whatever you want.
Yeah.
The question is, should you do it? And we don't have good guidance around that yet.
Yeah. We also have to be careful because John is tempting fate by wearing a blue screen of death t-shirt.
He sure is.
Although it's all about the green screen. I was thinking as I put the shirt on, I was like, I haven't seen a blue screen in forever. And then I was like, oh, but I get green screens now. So it's the inside.
I was being careful not to mention the fact that you had that shirt
just
on
in case
today.
it happened. Yeah.
Well, I am running on a Mac, so it's kind of unlucky.
There you go.
But... All right, so I started my deployment, and it did deploy. It took a while. There were 5 services. Redis is up, and I can hit my app. This is great, right? But you guys want to see the magic moment, which is how can I debug in there? So let me actually first jump over to my code and actually set a breakpoint somewhere. Oh, funny enough, I had this breakpoint. I never took it out. Okay, so I'm going to F5. I should probably show you what I hit at on F5. So I have 2 profiles, one for attached to the front end, one to attach to the back end. So I picked attached to the front end, and I go ahead and hit, it gave me a process ID selector, and I picked PID1. I don't know if people saw that. I went through it real quick.
So what you're saying here is you're running the VS Code. What you're doing here is running the VS Code side of the debugger now, and you're saying basically attach like you would attach
Let me
to
just do it
anything on
again,
your local
right?
machine. But in the attach dialog, you say I want to attach to the container running on Kubernetes.
So there you go. I went back to this.
Yeah.
So
There's no information saying that's the one on AKS, but we know that PID1 is only going to be something running in a container. Is that
so?
Or is it?
What is
no.
that?
So
What is that crazy one with calm? Ah!
So we're actually, I don't know what that is. Yeah. But we're actually, we're past that point, Glenn. This is, the debugger already has connected to Kubernetes. It knows the right pod. It has the pod selector set up too.
Okay.
That's the magic of the Cloud Code VS Code extension. And now it's just asking me in that pod, which process do you want to attach to?
I see. So there's 3 processes running within your thing, and that's what that one with the comma thing is just something else running in that pod.
Some other process in there. So I go ahead, attach to PID1.
Right. So there's a lot of magic here then. So this thing knows how to find its way to his cluster, find the service, find the front end pod, and get the information of the processes that are running it, and then ask you which one you want to attach to, and then let you attach, and then hit a breakpoint in a cluster running on Azure from your local machine when traffic hits it.
So I go ahead, hit my endpoint, and if everything goes well, my breakpoint should be hit. It's taking a while, so I guess that's a good thing. If not, you just have to believe me on this.
When you add a comment, it hits there, right? Is that what you did? I didn't see what you did.
No, I just I made a request. Oh, there you go. And my breakpoint got hit. So my source code is local, deployed it into an AKS cluster, set a breakpoint in my local dev experience, went and made a request to my public endpoint, right? This is my cluster, and I'm able to hit a breakpoint in my code. That is back to John's question, some of these experiences are being made better and easier to get to, right?
Yeah. And if you if you follow Sourabh on the GitHubs, you'll probably find most of this stuff floating around in his repos, I imagine.
Yeah. I will apologize. This is all experiments on my GitHub repo. Don't be surprised if you don't find any readmes, but you ping me on Twitter and make me feel bad about it, I'll add a readme. Yeah.
I think the thing to take away from a lot of these demos is that they were all using stuff that exists, stuff put together by various people, but if you don't know it exists, it's impossible. Some can be difficult to find. As what Sourabh walked you through.
One thing I just want to call out there is it exists by various people, and it's not just Microsoft devs or whatever. This is like out in the. This is Kubernetes devs. This is the
absolutely
broader
like
open
that
source.
cloud, that extension that Sourabh just showed at the end was from Google. And as we saw, Sourabh went all through all this effort of lots of effort. He went through the effort of creating scaffold, creating a debug Docker profile, having this magic command that could let him attach, and then realized that someone from Google had solved this in an interesting way with a VS Code extension. Let me just go use that, right? And sometimes moments like that happen to us a bit, but yeah.
I like to say we used to have at least I hear before I joined Microsoft, we had a problem called not invented here syndrome, and now I want to say the team has transitioned to this new thing which I call proudly found elsewhere.
Nice. Okay, well, so as we're kind of wrapping up, there's a lot of great stuff you showed here. For some people that are kind of like, I'm still kind of mind blown. I don't even really know Kubernetes, or I want to learn it a little better. Yeah. Where's a good place to kind of get that?
So for Kubernetes specific, so the first I will answer a question that you didn't ask, which is cloud native in general. You should go watch Shane's show. It'll get into more Kubernetes, and you'll also see what the person who helped invent Kubernetes looks like, because Brendan Burns is in the first episode. For Kubernetes in general, the AKS, there is a bunch of tutorials about AKS on how to get it running. And if you go through the Azure docs on how to make an app and deploy it to Azure Kubernetes service, they're actually not that bad. They're actually reasonable. Okay.
I think, one resource I'd recommend is we have an Advent of Kubernetes calendar.
We do,
which is great bite-sized exercises. You can go through a couple a day. Great way to get ramped up on Kubernetes.
Yep. And then,
there's also a lot of learn modules on doing AKS and stuff on Kubernetes too. So learn.
Okay, cool.
I also mentioned too. We did mention the show, but on the Cloud Native Show channel, Brendan Burns has got a lot of kind of 5 to 8 minute shows, kind of 101 on what is Kubernetes, how does it work, and kind of just general knowledge about Kubernetes too. That he's done some cool things on a light board that is just good general knowledge on what is a cluster, what's a pod, what is orchestration, things like that. So just really good, just base knowledge, not just the deep dive topics, but the general stuff is good too.
Yeah. And I mean, awesome. we kind of shotgunned it here. We jumped around the place. We showed a lot of important things, some details that people will be over people's heads. I guess we could do a more 101 style community stand up if people want that. They should tell Galloway. The community managed to make this episode happen. So
yeah. Let me know if you'd like to see a more kind of intro level thing. I think that actually could be really useful. Cool. All right. Well, we're a little over an hour. The great show. Thanks a lot for for being on, for showing the demos, and then also cool to have this Cloud Native Show crossover. And so watch the Cloud Native Show as well, and that'll be included in the links.
You'll definitely get to see more of Shane's glorious beard.
That's right. Right.
All right. Thanks, guys. Appreciate it.
Yep.
All right. I can't do dramatic zoom out anymore, but I can press the end button.